Up to now, I haven't really explained how to pass strings to functions and return strings from them. That's what I'm going to explain now. You can pass a string to a function using either the character array, that's the square brackets syntax, or using a character pointer, as I've done here. Now, to return a string, you declare the function type as char star. Here's an example of returning a string with a maximum length of 100 characters, and that's defined by max strlen. That's the defined constant up here. And note that it's the programmer's responsibility to ensure that this length is not exceeded. Here, the string to be returned is creating using the strcat function, which concatenates, that it adds on one string to another. In this case, the greeting array is returned from the function, and that has been declared outside of the function itself, and that ensures that it continues to exist outside this function. In other words, greeting is within the global scope of the program. I'll explain scope in more detail in the next step in this course. Now, with this function, I can call it like this. So I've passed to it the string Fred, and it returns the result that's stored in the greeting variable. When that result is returned, it's passed to the printf function. Let me just comment out the call to the next function, which I'll explain in a minute. So let me just run this. And it displays hello Fred as expected. Now, often you'll want functions to return strings that aren't declared globally, like this greeting variable, and that's what this other function does. String underscore function dynamic. Now, it turns out this is a bit more complicated to do, because in order to do this safely, you have to set aside a bit of global memory to hold the string that you want to return. To do that, you can use the malloc, the memory allocation function. And that allocates space for the string on a global memory area called the heap. But why do I need to allocate memory like this? Well, to understand that, you need to know a little bit about the stack and the heap. Any local variables that are declared inside a function are allocated memory in an area known as the stack. When you exit from a function, the variables on the stack are cleaned up. To all intents and purposes, they no longer exist. So it's not safe to create strings inside a function and simply return those strings to code outside that function. To do that safely, you need to allocate globally available memory so that the strings continue to exist in that bit of memory both inside and outside the function. The malloc function allocates space in a part of your computer's memory called the heap. Variables that are allocated on the heap continue to exist even after you've exited the function in which they were allocated. So that's why I've used malloc here. Now I have to tell malloc how much memory, that is how many bytes, I need to be allocated. It doesn't matter too much if I allocate more memory than I really need, but it could be catastrophic if I allocate less memory than is required. In this case, I've decided to allocate 100 bytes, and I've defined, as you can see up here, the max strlen constant to be 100, and that's the definition that I use to specify that I need 100 bytes for a normal 100 characters. Notice that I've had to initialize the array s with a null character by assigning the integer 0, and that has the same effect as assigning a null char. And I do that before attempting to concatenate another string, such as hello, onto it. That has the effect of making s an empty string, one that contains no printable characters at the outset, but does have a null terminator. Without that null terminator, the s array might contain random bits of data that happen to be lurking in the computer memory. And that's going to have completely unpredictable effects. So be sure when you use strings that they always have at least a null terminator. Now let me show this in action. So I'll uncomment this again. So this time I'm going to call both functions, the one first of all that uses the global variable string underscore function, and the one that returns a string variable that was allocated using malloc in string underscore function dynamic. So let me save that and run it. And the results are as expected. So in the dynamic function, it displays hello Mary. That's because I've passed to it the string Mary. It's allocated a string inside the function, set this null terminator, and then it's concatenated hello and a new line character and returned the string s. So it all works correctly. What happens though if I forget to allocate memory? Run it again. What happens is this. So first of all, the first function, which is not dynamically allocated, that executes and it returns hello Fred. Then the whole thing just stops working. It crashes. So that's the sort of consequence that can result if you forget to allocate memory. So it's very important to do that. What now happens if I try to concatenate a string, but the s char pointer doesn't actually point to a string or an array that contains a null character? This is going to be unpredictable, so let's run it and see what happens. Well, my program doesn't crash, but you can see that instead of hello Mary, I've concatenated this string onto some random bits of data that have been lurking in my computer memory. So I need to make sure that I have a properly null terminated string before attempting to do any concatenation.